So let's start. Welcome to the DevCon. This is our third DevCon, and I'm really excited to have you over here. You've already heard Ali's keynote where he explained the smart society concept, and that's exactly what we are striving for over here at DevCon. So a little bit myself. My name is Ritesh Tyagi. I am the Senior Director of the microcontroller products, which includes all 8, 16, and 32-bit. I have MSEE and also MBA, and I've been working in the industry for a long time, and especially the microcontrollers, and that's what I live and breathe for the last 18 years. So majority of my presentation will talk about that where Renesas is heading, what we are offering to you today, and also what a new technology we're going to introduce, and at the end, if time permits, we will do a short demo over here. Some of you might have seen yesterday in the demo hall. But if not, it will be also available tonight actually. But over here, we'll try to give you some sneak peek about our next generation state-of-the-art 32-bit microcontroller. So let's start over here. There are 3 main technologies that Renesas offers today: the microcontroller and microprocessor, which you all know we are #1. Alongside, we have analog and power and SoC and ASIC product as well. So I'm coming from microcontroller, as mentioned earlier, and I will focus on that in the next 45 minutes. So all the smart society concept that Ali mentioned, I just want to take to the next level and really talk about that. What is needed actually to address that, and why this is happening? So I'm not sure how many of you have seen this diagram they call the PRISM, actually, social prism or conversation prints by Brian Solis. Actually, it's pretty a big media or digital guru actually, and he compiled in 2007 that let's take a look all kind of conversation that's happening today in the society, whether it's a machine to machine or man to man or man to machine. All those are connected somewhere, one way or other, with a very real time data processing. So everybody wants the data in the real time. So real time is the prime time right now. Earlier, the data were kind of very sporadic. The people were getting this data in an intermittent level, but now they want pretty continuous. So it requires a lot of horsepower to process around that. According to IBM study, they are saying that every day, the amount of data actually that board is producing or processing is quadruple. So every day. So that's a pretty large amount of data that we need to process. And then, since more things are connected to the internet, again, you need a lot of horsepower, a lot of memory, and also the technology which is conserve the power. And that's what I will talk about, that how we are addressing all those needs. So one other area is that what's happening, there's a lot of information overload, a lot of data, a lot of information, and can you process it? How can you process it efficiently? So people say it's a problem, but actually it's an opportunity to really make the society more smarter by taking advantage of a lot of information that is available. And then the last element comes is that privacy or security, which Ali mentioned a little bit, and that's also we are going to address, and I'll explain it in my presentation. For all the things, if we combine together, then okay, how much power do we have, and how much power are we going to consume? And as you have heard just 30 minutes ago, the power is the key, and what we have been doing in every technology that we are going to introduce you, there will be some power consumption element. So let's move on and see the trends, some of the trends that how the memory requirements or CPU performance requirement was actually going on in last like 40 years. So starting from 1980s to 2010, every 10 years you're seeing that the processing capability is going dramatically high. In the early 80s, people were using just 8 and 16-bit controller, like 2 to 5 megahertz processing capability. Now you see very commonly people use 200 megahertz of microcontroller or microprocessor in many of the designs. So multiple fold from a performance standpoint, requirement has increased, and the capability of the microcontroller has been increased. The other angle, the processing performance increase is understandable, but then now memory requirements also increasing. Every decade we see that the memory requirement goes 8-fold. Starting from 1980, where microcontrollers were very small, 2 kilobyte memory on board or 16 kilobyte memory on board. But now people are talking about very commonly megabyte or up, and in fact there are many applications where people talk about 8 megabyte of onboard flash memory. And please realize that I'm talking about embedded flash on the microcontroller, not this, the external memory. The external memory, yes, you can use it, but that comes with some other price point because there is the security issue, there's a performance hit. So people start asking that, hey, why can't you introduce or include embedded flash up to 8 megabyte? And that's what we are doing right now, and I'll explain exactly where we are heading. So with that, next 45 minutes, I'll talk about the process technology roadmap. Also, I'll talk about the architecture from the performance and memory integration standpoint. And then at the end, some key innovative integration from software standpoint or the solution standpoint that I'll touch upon. Hopefully, at the end of this presentation, you will get a good idea about Renesas microcontroller and microprocessor technology. So let's start. The first topic is the flash memory technology. This is the very unique differentiation that Renesas brings to the market compared to any other vendor in the world. There are a lot of microcontroller manufacturers available. They do use their own technology or TSMC. But all those flash technology, they can't run more than 40 megahertz single cycle. But Renesas is the only one where we can offer 120 megahertz single cycle execution. Why it does matter? And I'll explain you later on in my presentation. There's a major penalty if you don't have that kind of technology. You can't embed a large amount of memory on board because you have to process that amount of data pretty efficiently. And if you have a bottleneck with only 40 megahertz memory, then no matter what your CPU works, CPU can go up to 400 megahertz or even gigahertz, but the moment you have memory access, you have a lot of penalty. So what kind of technology we offer? We have this Monos technology, pretty unique, and some of you must have known that recently we have licensed that to TSMC. Now TSMC will use this technology as well, and we will further do a joint development. Right now, we have announced yesterday our 40 nanometer technology for RX. A few months ago, almost 6 months ago, we have introduced our first RHV850 based technology using this same 40 nanometer process. So this would be our flagship technology for all of the 32-bit microcontroller that we're going to introduce in the marketplace in next few years. And that's a major advantage against any other competitor in the world. People are still struggling to really productize the 90 nanometer technology, where we skip 65, 55, and go straight away to 40 nanometer technology. But that's not all, because for smart society, you need a different solution for different things. This technology is geared for high performance and also large capacity onboard memory. So there's another technology that we offer for the power sensitive, lower cost application, which is NOR-based split gate technology, where we have our low-end microcontroller, the RL78, which Ali mentioned is a true low power technology dominant in the marketplace. That is based on this technology, which is 130 nanometer, going up to 40 megahertz single cycle. So after that, they would wait state. But most of the controller, which require the low power and lower processing capability, would be very good enough to operate at 40 megahertz single cycle. Now, again, as I said, the key for this technology is low power and low voltage. It can go up to 1.6 volt operation as well. So these would be the two dominant technology area that we're going to focus on, and the most of our controllers will be based on either 40 nanometer, 120 megahertz Monos, or 130 nanometer up to 40 megahertz split gate technology. How do we compare against competitor? We had an option after 90 nanometer to go to 65 or 55, but we skipped those because we felt that this 40 nanometer has a lot of merits. It has a small die size, lesser gate counts, more cost effective, and also a low leakage. So compared to 65, 55, we have been able to put some special IP to reduce down the leakage as well. So a lot of benefit on this 40 nanometer technology. And it can integrate up to 8 megabyte of onboard memory, as you have seen on my trend slide, where people are talking about having the up to 8 megabyte of onboard flash memory. these technologies actually, how they're helping us, and actually what you see today, a lot of time people ask that, oh, these technologies are for automotive or for only non-automotive world. So this slide I put together to give a snapshot that how Renesas is different than any other vendor in the marketplace. If you see our revenue, we are #1 worldwide in microcontroller with 27% market share. Almost every third microcontroller in the world, one way or other, is coming from Renesas. And that's a pretty dominant position. So we have some responsibility to really address the customer and market need. So over here, if you see this around $4.2 billion revenue that comes from microcontroller, we are pretty evenly poised in an automotive and non-automotive world. There are a lot of other vendors who are just focused on either one side or other side. Only Renesas and Freescale to a certain extent are really ubiquitous. They are really serving both market with the same emphasis. So that's what the key is, that we need to have a different technology which goes in the automotive world or non-automotive world because the requirements are very different. Now, why we chosen the 40 nanometer technology? Because this is very well suited for a harsh environment in automotive. Can run up to 125 degrees C with a very high reliability and very high write array cycle. So that's what's the reason why we wanted to have in such a fashion, in such a way that all the technology can gear and address different market needs. So how does lineup look like, the microcontroller lineup? So how many of you attended the 2010 DevCon? A few people, that's correct. So you guys must be very familiar with the left-hand side, and that was right after the merger with NEC. And we had the 5 cores that we have been focusing on at that time. Right after that, we started looking at how we can consolidate and take the key technology from both sides and come up with the next generation technology or product line family, which can cater the wide variety of customer demand. So on the high-end side, we have launched the RH850, which is, again, based on 40 nanometer technology, only focusing on for automotive. Has a lot of specialized peripheral, specialized software support, and also this 125-degree operation support. So all of the existing customers who've been using V850 or SH, when they start looking at next generation, then RH850 is the way to go. Now, on the mid-range 32-bit family, which we call RX, which was our flagship microcontroller family we launched in 2008, is going to continue, and that's our major focus. We are expanding that. Yesterday, we announced dramatic expansion of RX family, and I'll touch upon later on, where we're expanding up and down both sides. And that is going to be our flagship microcontroller family in the mid-range. Now moving from 90 nanometer to 40 nanometer now, and that family will also be covering pretty wide spectrum. And the low-end side, you heard, listen, there are a lot of lectures on RL78, that this family would be our major flagship company, really, really offering true low-power technology. So technically, now these 3 cores are going to be our focus in future. RL is RL78 for low end, RX for mid-range, and RH850 for high end. Let's talk about the processor, because this is a big market where people are using the ROM-less device, basically external flash, cache-based system, Linux operating system. And definitely we need a lot of horsepower and computational power. This is the first time we announced, just yesterday, that Renesas is expanding and going to use ARM architecture for the microprocessor family. And the first one that we announced, called RZ, going to be very much focused on the application specific, especially in the, for example, high-end HMI market, human machine interface, the graphic interface, offering a wide VGA or XVGA support. A lot of processing onboard SRAM, up to 10 megabyte of onboard SRAMs. Very unusual. People don't have that kind of integration. But because of the 40 nanometer technology that we do have, we can integrate both flash as well as SRAM on board. And this will help designer out to design the system without using the external memory for the graphic image storage. And that's what could be the first that we are launching, and early next year, we will provide more detail. And then moving forward, the same way, we are going to use the other ARM core to go to the high-end connectivity side as well. So this microprocessor supporting Linux and other operating system will expand in future, and that will be mainly based on the ARM controller. So with that, let's move on one by one and give you a little bit, one more level of detail so that you can understand that where we are heading. So let's start with RH850. So let's talk about the core itself. There's a lot of investment we are doing to develop these next generation cores. And it's not a one-shot deal. There are a lot of investment we have made in past, and we're going to continue in future as well. So for example, the V850, there were a lot of different cores we've been developing and offering to the automotive world. Similarly, on SH side, we did offer a lot of from SH1 to SH2 and SH4A class of processors. Now we merged both two. We said, okay, let's take a look where we can bring the best technology. We took the core architecture from V850, but a lot of peripheral from SH, and this RH50, there were two versions. One called G3M, which has been focusing on mainly high performance side, and the other was G3K, which is mainly focused on body control application with a low power. So that's what and then moving forward, we're going to continue developing these two areas where performance is the key. We will take the high performance core or the low power. So technically now we are covering the entire automotive spectrum, and that's the first time actually. No other vendor can be able to do that till now. Now the one device, one family, one architecture will cover the entire automotive spectrum from body control, airbag, to all the way to engine control unit. How this will look like, the overall spectrum, starting from 48-pin device to go to a 357-pin devices, covering from 256 kilobyte of onboard memory to go to 8 megabyte of onboard memory. So that will be the entire spectrum. And if you're interested to learn more about this family, the lecture that we're going to have is the 1C06B. That you can go and attend and learn more about this automotive family, where they will talk about in detail each of these devices and their uniqueness. Moving forward, the next section would be RX. So today, most of you must have seen that the RX 200 and RX 600 is the main flagship series within the RX architecture right now. So the RX 600 and 200, when we launched that in 2008, since then we have expanded dramatically. Right now, around more than 450 different products are available in the RX family. And again, I repeat that this is our flagship controller, and you can see over here the lineup that it covers. Starting from 48-pin, 32 kilobyte of onboard memory to 2 megabyte today. That is available in mass production. All the devices are available. So you can choose from many different versions, and you can see how this is the best thing is scalability. A lot of time customer ask us that, hey, yes, you do have, I'm using a 64-pin device, but the moment I go from a 64K to 256K or 512, I have to change to the next package. But here, you can go from, within 64-pin package, can go from 32K to go to all the way to 512 kilobyte. And that's the beauty of this family, which has been pretty much appreciated by many of our customers. So what's next? This is almost 3 years we have been offering to the customer. They love it. There are a lot of designs. And actually, there was yesterday, some of the press people have heard, so far we have won in last 3 years more than 4,000 new designs based on RX. And that sort of magnitude that I want to explain, that how popular this family is. Despite all this things that, okay, ARM versus RX or ARM versus this, the whole point is that, do I offer a best system solution? And that's a testament that people are using RX left and right. So based on their requirement and the request, we listened to them and said, okay, let's see what we should do for next generation. So there's two types of development we need to focus on. One is the CPU core, and then we start looking at the peripheral and the lineup development. So I'll talk about the CPU core the first. And again, we are constantly investing to improve the CPU core of RX. So first generation, we all know that 100 megahertz CPU performance, 100 megahertz single cycle flash access, and it offers 3.12 core mark per megahertz. The best core mark result in the industry. There are two ways people measure, either core mark or the DMIPS. Both sides have their claim, counterclaim, what is the best way of measuring. We offer both. And then in both sides, if you talk about the DMIPS, 1.65 DMIPS per megahertz, best in class in the industry, and also the core mark 3.21, best in the class in the industry. So next generation that we have announced, the RX expansion that you have heard in the press last night or today morning, is going to be V2 core that can run up to 240 megahertz. And the flash will run up to 120 megahertz. So after that, you will have one wait state, but that's okay. We are bringing the memory accelerator, and that will reduce the penalty of the pipeline stall. So it's still 3 times better than anybody else in the marketplace, from 40 to 120 megahertz single cycle flash access, and going to offer up to 350 core mark per megahertz. And we are expecting it's going to go up to 3.75 with the advanced compiler techniques. So that's what's going to be overall roadmap. And then the 2 areas that we are continuously going to improve, of course, the higher performance, to take it to up to 300 megahertz or beyond, and also make it smaller and smaller on a die size standpoint so that you can get the best the cost structure. So how the roadmap will look like for RX, and there's a tagline that we are using, and you will hear constantly during this DevCon or after that as well, 8 to 8. We are the one who can offer 8 to 8. What does it mean? Technically, this RX architecture is pretty unique. It can cover from very small 8 kilobyte of memory to 8 megabyte of onboard memory. So that's the magnitude of the overall spectrum that it covers, and that you can see from different series that we have offered. So again, very familiar with RX 600 or RX 200. All of you have known that already. This has been marketed for a long time. Now, for us, the natural migration would have been to go to higher side, because RX is a 32-bit family. People want some more integration, more performance. So yes, that's the one area that we have decided to bring the product called RX 700 family, going to be up to 8 megabyte of memory, a lot of peripheral like dual Ethernet, the higher DSP capability, graphic solution, and all kind of stuff will be there. But then we also listen to some of the customers. Some customer says, or I would say a group of customers ask that, we want a 32-bit continuum or 32-bit up and down. Can you offer me something at my low-end need as well? And in the beginning, we kind of understand that there is some inherent benefit of going to the simple 16-bit controller. 32-bit architecture brings some inherent issues because you have bigger pipeline, you have wider buses, you have a lot of other stuff which probably not suits you with very handheld battery power application. But they were pretty persistent, and they said, no, I think you have a good technology is low power. Why can't you use the same technology that you use on your 16-bit controller? We said, aha, that's a pretty interesting thing. And that's why we developed this RX 100. That's also been launched in this DevCon. Here's the demo that I'll show you. And again, before I go detail, let me share the story. When we're developing this RX 100, or I proposed with RX 100, everybody in the organization was very apprehensive that can we achieve it? Because this architecture, this core is bigger, and then we've been using the 90 nanometer Monos technology for RX, bringing a 130 nanometer technology. How are we going to handle that? So finally, our designers actually took the challenge, and a record time. This is a record time, the start to finish. In March, in actually April, we freeze the spec of this controller, and in September, I had the first sample in my hand. It was a record time that they have developed, and this family is truly lowest power 32-bit platform. How many of you have attended the Freescale FTF? Great. So hold your refresh your memory for next 10 minutes, and I'll come to that slide and I'll explain what kind of the information they shared and exactly what the true situation is. So, yes. Yep. So we do have all the SRAM single cycle, and as mentioned, if you look at that, remember the RZ family, up to 10 megabyte of SRAM we are offering. Also on the RX side, we can go up to 512 kilobyte of SRAM on board, and this is the good segue where this RX 700. So the 700 side, if you talk about the memory integration, 8 megabyte of flash and 512 kilobyte of SRAM. People talk about 64, 128 at the max. Nobody has more than 128 kilobyte of onboard SRAM. We do have 128 kilobyte of SRAM today, and this RX 700 will offer up to 512 kilobyte of SRAM. So the whole concept of this RX 700 would be higher performance, more integration, a lot of different functionality like trusted memory interface, event link controller, and high speed A to Ds, 2 megasample per second A to D. So all those things are geared towards more performance enhancement. And then, of course, a lot of flexible package sizes we are going to offer, from 64 pin to 256 pin of packages. And don't forget, bridging the gap between analog and digital world. So a lot of analog components are integrated, whether it's a comparator or A to Ds or op amps or so on and so forth, temperature sensor, etc. So, but major focus would be towards the high performance side. Let's talk about the RX 100, and that's what I wanted you to refresh your memory from FTF. Give you some foundation things. Typically or inherently, there are some benefit in the 32-bit architecture. They brings the performance. They offers more integration. There's a large ecosystem available, it looks like. And of course, their power consumption side, there was not a lot of effort. So there are definitely the power consumption a little higher because the way the flash module has been set up for the 32-bit controller, it's inherently larger compared to 8 and 16-bit. So there's always be a penalty in by using the same flash module or same flash control logic because it's a little bit bigger. When you talk about the 8 and 16-bit world, they are designed for a very low cost point. All the controllers you can see today, 8 and 16-bit, are $1 or less. You can find majority of them, right? So that's the first things that they focus on. Of course, the power consumption also, the area. The fast wake up they talk about that, hey, because the overall power should be taken care of, and then a lot of analog integration and scalability. So what we did, we start thinking about how we can bring best of the both worlds. Bring the good feature of performance from the 32-bit world and takes the low power technology and cost sensitivity from the 8 and 16-bit world. And that actually brings the RX 100. Offered pretty high performance because same RX core, RX 200 core that can run up to 1.56 TMX per megahertz, which is much, much higher than majority of the 32-bit controller available. And I'll show you next slide. Very low power consumption, 1.55 microamp per DMIPS in active, and only 0.3 microamp in standby mode. For a 32-bit controller, this is phenomenal. Less than $1 price point, you can get the devices over here. And it's part of RX scalability, 8 to 8. And of course, similar ecosystem. All the ecosystem that we developed for RX so far in the last 4 years is going to be used exactly same ecosystem for RX 100. So ultimately, it is really truly combining the best of the both worlds. So let's take a look very quickly how this compares against any other controller in the marketplace. So RX 100, 1.5 DMIPS, Cortex M4, M3, and M0 Plus, where when I mentioned about basically FTF for kinetics, that's the family that they or CPU core they use. Only 0.93 DMIPS per megahertz. Then the other argument was core mark. Okay, the core mark is 1.77 for M0 Plus, RX 100 3.08. So dramatically better. Okay, other angle. Low power leadership, and that's where I want you to refresh your memory. There are a lot of gimmicks. So this is right from the Freescale data sheets. and they talk about, they advertise this 1.133 microamp per megahertz. But technically, this is 48 at the peak, 48 megahertz. As they go below, because this is a low power application, people want to run clock at lower frequency. They're not going to run at 32 megahertz frequency or 48 megahertz. They want to run at 8 megahertz, 16 megahertz, 2 megahertz. And as it goes down, it really increases dramatically. This is correct. This is very normal. This is inherent. Nothing wrong in it. But we need to understand the right data point. Then let's compare on the active mode overall. When we run at the same frequency or same highest frequency for both Freescale and RX 100, and then I always keep the RL-17 in the picture, because that gives you a real base that, okay, what we're talking about, why this 8 and 16-bit, there are some value proposition, or this RL-78 has some uniqueness. So around 6.4 milliamps, 6.6 for RX. By the way, this is just a first cut silicon, no optimization, nothing, which you're seeing over here. But I'll show you a true value, no gimmick. And RL-78, 4.6 milliamp at 25 degrees C. Another angle, this is a chart that Freescale has put on their website, their presentation, FDF presentation. Hopefully you recollect that. They totally misrepresent over here. They said RL-78 is 1.87 core mark per milliamp. The argument has been twisted. I say, let's take a look at the core mark per milliamp. Okay, fine. Let's take that argument without any issue. Core mark per milliamp, M0 says 12.4 core mark per milliamp. RX use 14.9, RX 100. Yes, RL-78 is lower. It's 4.5, not 1.87. And actually, we took that discussion with the core mark, and core mark talked to Freescale, and they acknowledged the mistake. So this is the one where it's kind of a gimmick going on, and as an engineer, as a true, honest, unbiased press people, you need to understand the true value of the data and exactly the difference between what has been presented and what's right now. And everything has been taken from their data sheets over here and their FDF presentation. Now, that was the active mode. The most of this power-sensitive application requires to be run, and the most of the time in the wait mode or standby mode. Suddenly, you will see dramatic difference. Let's take a look wait mode. 1.4 microamp compared to 0.7, half on RX 100. But the RL-78, which they were comparing, and said, oh, discarded completely. It has a core mark, lower core mark per milliamp. Actual situation is this. It actually consumes very, very low power, only 0.49 microamps running in the wait mode with RTC on. And that's the engineer wants. So you can keep showing, as Ali mentioned, the one mode or best condition, but no, you have to show every condition that are we good in all the conditions. And that's what exactly is compared to the Freescale. Then there's another angle, the stop mode, which is standby, complete stop, but RAM has to retain. Yeah, I can show my data where without RAM retention, it has no meaning to engineers. I can show that data, no problem. It's even lower than that. I said, let's take a look with the RAM retention. Same 1.4 microamp in this mode as well for Freescale. RX further down 0.35 microamp, and RL-70 is the lowest still, 0.22 microamp. So these are things, but then one good, interesting point is that shows the technology difference against this M4 Freescale and us. When I look at that data sheets, and I'm sure you can't see that, but I would encourage you to go and look at the data sheets. In every mode, there are so many numbers, and all numbers are temperature dependent. Dramatic difference. So I said, yes, there is temperature dependency, because as you move from -40 to 85, the power number changes. But those should not change dramatically. So I took the same stop mode as an example and say, let's see how it is changing from Freescale from 1.4 microamp to 26 microamp. That dramatic change where we go from 0.35 to 5 or 0.22 to 3.3. So there is changes, but there are dramatic changes. And that's the technology differentiation. The kind of technology, the low power, low leakage technology that we do have, that Renesas has, is very different than the other vendors are using. So what is the key takeaway? It's not that this product is bad. No. The key takeaway is that engineering community has to know about what is a true, or what is just a specmanship. And that's what RX 100 is, or RL78 is. So we are sampling. This RX is available. You will see the demo over here later on. And if not over here, then you can see the demo in the demo room, actually. And hopefully you've seen yesterday. But not, then please, I encourage you to go there and look at that. So overall, the same philosophy. We're going to have the performance side, same RX family, but very low power. And a lot of integration we are doing, which can give a low power overall in the system level. And multiple level of multiple different devices are available, from 8 kilobyte to 512 kilobyte of memory on board, with lots more SRAM. So, in a nutshell, this is going to be a true low power 32-bit platform. RL78 is still our lowest, going to be our lowest power platform from Renesas and in the industry. RX 100 would be lowest power, lowest cost platform for 32-bit application. Again, later on, please take some time and tonight go and see, and I will show exact those numbers. All the number that I've shown you, 6.6, you will see exact that number, 6.6 running on there. No gimmick, no nothing. Last section, or third section basically, is RL78. Again, overall roadmap, when we started that after the merger, there were two families we look at that, R8C and 78K, which are very popular from NEC side and Renesas side. And what we did, we merged those two together and really created the two different versions, G13, which was our first generation, which we have quickly come up with as a amalgamation of these two, and then G14, where we have added a lot of more functionality from R8C side. So this family offers up to 44 DMIS performance, and again, the low power is the main functionality and one more feature. We are not looking at to enhance the power or enhance the performance more, but more and more we are looking at to really keep the low power aspect of this family. So again, now I will give you some again data point against other 8 and 16-bit world, where we do have a TI MSP 430, AVR from Atmel, or from Microchip PIC 16, and also from ST SM32L. So the one hopefully you remember in Ali's presentation, the technology has to be employed in such a way that it can offer the lower power in each mode. So in every mode, when I talk about the run mode, RL offers 144 microamps per megahertz. I also put over 66. What is this? This is no-op. A lot of people are advertising, and if you go to the Atmel website, the latest Atmel device is launched, and they had a big, 72 microamps. But that's no-op. No-op has no meaning. But it's still, if that's the case, then I will give you data point with the 66 in case of RL78. When you go to the halt mode, 0.49, dramatically down, and also from stop mode. So we have pretty gradual decrease, and that should be the behavior that we all expect. That controller goes from active to halt to stop. It has to be a gradual decrease. But in compare other people, for example, if you take a 1B, for example, active mode, yes, pretty comparable, but then it goes to the halt mode, dramatically up. So that's the problem of this technology that other people are deploying in this microcontroller, and that's what the true differentiation for RL78 over here. So overall, there are three areas that we are developing this the RL78 expansion. The one is general purpose. The multiple devices you will see over here for very, very low cost, 50 cents or above, and even lower actually in some cases. And then we have the same devices adding the segment controller on top of that, very much pin compatibility. And then there are a lot of application-specific devices. For example, for automotive, or for lighting, or for metering, and so on and so forth. So where we are adding some application-specific peripheral. How this will cover the spectrum? Very similar. The philosophy is same, that whatever we do, when we are going to launch a product line, it has to cover the entire spectrum. There will be some overlap. People say, hey, why you are going up to 512 kilobyte? Because now you have an RX in that zone. Yes, there is. There will be some overlap, but there are two set of engineering community who wants to take advantage of these two different architectures and offerings. I can't say that, hey, just only use RL78 up to 16 kilobyte and then move on to the RX. No, if you want to be in RL78, go up and down. If you want to go in the RX, go up and down. And that's what that's a little bit investment from our side, but it's worth it to really solve the pain of engineering community. And that's what we want to do. You can learn more. There's a course called C04, actually, that's going to run tomorrow and actually today. And you can learn more about RL78 in detail. There's two other areas that we talk about, and as Ali gave you some sneak peek about this, smart analog. So RL78 is kind of our backbone for most of the low power implementation. And we are already offering a lot of analog integration, like op amps, temperature sensor, etc. But then people want a little more complex analog. They want at least 5, 6, 8, 9 op amps or competitors. In that scenario, we do have a family called Smart Analog that has been recently announced and launched. What it does, it basically brings the microcontroller and all the analog into the one package. And you will see the multiple flavors and multiple variants of this is going to be available in the near future. And that is mainly geared towards the building automation or the factory automation where you want to use a smart sensor. So technically, all the decision, all the data processing can be done at the sensor level. So we are making these sensors more smarter as opposed to dumb sensor today, where they're taking the information or the ambience information and sending back to the central processing unit and processing there and taking action back. Monolithic. It's called single die, actually. Single die. It's a single package, actually. 2 different die inside right now and single package. The next generation will be true monolithic, which we'll talk about integrating all this feature into over here. The other area is that not only we are looking at on an MCU standpoint, but also we look at that in the true application area, because display technologies are really evolving dramatically. And we say that, okay, how we can partner with some of our key partners to offer a solution which is pretty good. They're a good marriage between the RL78 low power technology and also some of the low power display technologies. So E-Ink is our partner, is here. They're showing. So we have really developed a full-blown solution where, based on their technology, which is pretty attractive, pretty thin, and then low power. You call almost zero power, because when you see in the static image area, consuming no power. And it's been very popular if you see Kindle Fire or other applications. That has been used, that technology has been used there. So now there could be multiple opportunities to use that technology because it's a pretty flexible. You can shape it, change it. A lot of wearable sensors you can use based on this technology. And that's what this RL78 whole solution that we have developed that anybody can really take advantage of. And again, you can see this demo next door. So the last section, we talked about the hardware. Let's talk about the software. Nothing is complete without the whole software package. And that's what we are looking at. We have just announced, again, our full-blown DSP library with all type of almost 32 types of different complex math instructions, which is going to be available free of charge. We are not asking any money from our engineering community. They can access, they can download just by simple click-through agreement. And in addition to the DSP library, there are like thousands of free sample codes are available on our website, which you can use as it is or use as a reference to implement in your system. The other things, the Power of Two, which you're seeing or hearing continuous theme, we partner with Micrium and their real-time operating system, which is pretty robust and highly rated in the industry. That, with all of their middleware, the entire package, which is more than $100,000 worth of the whole package, that is offering now free of charge. So all of you, actually, technically all of you who are attending this DevCon, if you go back and just go to our website and say, I want this package free, and if you have intention to use RX or RL in your commercial production, you can get the entire package free of cost. Royalty-free, free of cost. And it comes with 1 year of the free support as well. So it's a very nice offering that anybody can take advantage, provided the only condition is you are going to use RX or RL in your commercial production. So, as a summary, what do you care about? Of course, the dollar. Of course, the money. That's the bottom line. Definitely that. And sometimes conversation starts from there. Nothing wrong in it. That's exactly fine. But then after that, you should think about both macro and micro level. The macro level thing is that any processor controller that you're selecting, whether it can capture the 3 elements, it has a processing capability that can take you from point A to point B or beyond. It has a lot of connectivity angle because as we talk about in a smart society, you are going to connect your solution one way or another with the internet. So can you support that? Can you go up and down in this family? And third, which is most important, is power budget. It is really within your power budget. And then after that, the macro level is, yes, it's a great family, but do I have good support? Do we have a good tool support? Does it have a good mix of peripheral set? All those things have to be combined and should be looked at in tandem. And that's what we talk about, all the things that I mentioned over here. Not only we are addressing from our technology this element, but also we are addressing with our software package and our partner support, the overall user experience should be great. And that's very much it that we would like to ask you to take away from this presentation, that Renesas is not just a silicon vendor or just a chip vendor. Renesas is a solution provider, and we are offering the entire solution as a complete package. Good. Thank you very much for attending. Great session. Thank you.